Worked in general, past 20 years, 10 years in corporate, 10 years different startups, and now doing these 2 startups. And today we want to talk a little bit together about what we're all doing in this agentic world that is emerging. And I want to start with that question. How many of you might have heard of this person? Vannevar Bush. 1, 2, 3, excellent. So and who might have read this paper, as we may think? Excellent, I'll have to talk to you guys later. So this I'm going to submit to you that probably is, it's a paper from 1945. It's probably, a very good summary for all of the vision of computer science and AI and probably human destiny, right? And he takes it also at that level and does make that impact in the years to follow as well. He does very straight on, talks about, extending man's physical power has been the job of most of the tools developed so far. Now we have to extend the man's sort of mental capabilities and the mind using the new tools. So it's all about knowledge and the role of knowledge in a very broad sense in the human life and how that can be navigated and how that can be used. And that he submits as the kind of the most important calling of all scientists, and this was right after World War, and he was the key person in charge of all of the R&D of the US. And as the war finished, he was trying to focus that scientific kind of crowd onto a much larger mission, and it worked out greatly. And in this paper, he goes very specific. It's like an 8-page paper, 8 to 9 pages. I read it again completely yesterday in preparation for this talk. And it describes this machine called memory index, MEMEX. And there is actually a sort of a interpretation built of this in the Technical German Museum, that the picture is there. And essentially a desktop in which you're kind of, put, like every piece of information comes to you, you can kind of record it, you can scan it, you can then it's stored for you and you can consult it, as he says, this record of knowledge at your will in a very kind of an interactive fashion. So he talks about extending that record of information, storing that and consulting it in a very extensive, very nice fashion. And he goes on to explain how it's going to extend and help navigate the human knowledge and how that is so important, because even back then, the production knowledge was so fast that it was very difficult for scientists to keep up with actually the consumption of knowledge. And that balance is something that is key to kind of think about. And he goes even deeper. We have to really observe how the creative men think, and he puts this focus around associative learning or associative-based types of memories that are very also important in general in sort of learning systems. And he sort of imagines even voice-controlled systems, and he explains logically how they can happen, user-propagated learning, which is essentially personalized learning, and all of those things very nicely come together. Bear in mind, at that time, there was the first attempt at building a computer ever, and that's the picture from it. This is a mechanical computer from 1937 from a guy here actually in Berlin, Konrad Zuse. At 25, he started working on this. First attempt, Z1, Z2, Z3, reached a level that had also some commercial usability. And it was destroyed in the war and the bombings, and it was rebuilt later on in a project, and it's also in the museum here. That was taken up by another guy, Douglas Engelbart, in 1963, and he got very inspired by this paper from Bush, and he then created a more practical framework called a conceptual framework for the augmentation of man's intellect. And he spent his life on it, and he delivered a seminal outstanding demo, which is now retrospectively called the mother of all demos. How many people might have watched this entirely? Outstanding. So I think we have, a couple people who have, but this is something I think like first day of any university, any computer science, AI-related course must be there, because this is what led to everything from if I've just highlighted there for you, from personal computing, including Windows, hypertext, graphics, navigation, command input, video conferencing, computer mouse, word processing, dynamic file linking, revision control, collaborative real-time editing. This is 1968, and in his demo that is available on YouTube, over an hour and a half, you can see all of these things in reality in that research center. That, some 12 years later, is then, of course, picked up with, by, for example, Steve Jobs, shaping the overall PC revolution. That's in 1980, and if you've been listening to Steve Jobs, he puts a lot of emphasis in this computers being the bicycle of the mind. This emphasis of extending the intellect is very, very strong there. And that's a newspaper ad from Apple from 1980, and he explains there that, on the chart on the left, that he was amazed when he saw this newspaper ad in Scientific American that, that the human being on its own doesn't have a very good rating among all the animals when it comes to walking or running, but on the bike, it's way up there, faster, more efficient than anything else. And that's a very important mental shift. There's many other milestones in between, and then we had the 22, sort of a breakout of ChatGPT, and some 42 years later from that point of time, from Steve Jobs, let's say. And then these remarkable coming together, these three people, Ilham, Sam, and Ilya, among the other people, made this thing that we could not have imagined that will take place in our lifetime. As, let's say, AI PhD students 10, 15 years before that, it did happen, and it became a reality. Of course, there's many other milestones in between. Google itself that I skipped is essentially about navigating, organizing all of the world's information. So what is very interesting in all thinking, when we think about products, overall evolution of the world, is like, what are the problems and how human beings are kind of trying to solve those problems. And if you get the good grasp of that, the real problems or the real underlying nature of the problems are kind of almost like timeless. Technologies come layer by layer. We try to solve these almost like same problems. So we will always need to eat, and we will always need to wear things, and we will always need to have knowledge, and that's probably our primary function. And we want to be able to navigate this knowledge and learn from it and kind of reach wisdom. And hence, this knowledge navigation management is super key from a sort of broad sense, and in a more specific sense, sort of this knowledge record management, or this record of knowledge, as Bush puts in that paper, which essentially the record of knowledge at our times of this file. So it's like, how do you work with these files and the file management, something that we'll talk about a little bit later. But essentially, all of this is possible when you have so this pyramid, hopefully many people have seen, data, information, knowledge, wisdom. Summarize all of that. Key point here is that there is an abstraction. And this power of abstraction, the role of abstraction, all these things coming together, super key in information theory as well. And when you think about that, what is happening in the brain, so essentially the brain is doing all of this, and with all the different functionalities that it has, it on the whole enables that kind of a remarkable holistic abstraction, right? And it does it via the neurons that it has. And if you look at the count of the neurons, you see that there is 16 billion neurons in cerebral cortex, which is the component responsible for the cognitive functions. And you sort of see the comparison. Of course, in that context, the overall brain, the elephant's got the biggest brain, but the human being, in terms of the cognitive functions, has got the largest brain. And in that sense, that 16 billion is a good number to keep in mind. 16 billion neurons, which are essentially kind of keeping state, is enabling human-level intelligence. Now we have this neural scaling, and we have neural networks, and neural networks have parameters, and parameters very much like, the neurons. So the count of parameters, I would argue, are kind of comparable to the count of neurons. And so we've gone from like 2018, way under 1 billion, to 2024 for ChatGPT, 1,500 billion. That's 100 times the count of neurons that we have in our brain for cognitive function. That is resulting in comparable intelligence in many aspects. And in many aspects, it's already far superseding the types of intelligence that human can keep up with. Hence, and it's sort of amazing that it's almost like available as if it's electricity, right? You can plug into it. It's almost like water or something. You can like just use it. It's a commodity. And that's why there is a sentence that sort of captures very nicely that AI is a new electricity. So you can then extend that mental model that you need these products that are using that electricity to do things. So there is electricity, then there's lamp. There is electricity, there's refrigerator. There is electricity, there is this, there is that. And so essentially where we are right now is a little bit like that. So this is kind of central at OpenAI and other places. And we have all these thin clients, and these thin clients are almost like the agents that we're building, and they're kind of tapping into that intelligence. And what's also amazing is that like you are talking, so essentially you're kind of programming in natural language. And Andrej Karpathy, who is also a significant person, both in OpenAI and Tesla, puts this way, that software 1 was sort of general programming. Software 2, we had all this machine learning, kind of black box programming, more statistical weighting. And then software 3 is that you're actually using natural language to tell the computer what to do, and it's doable because LLMs are programmable in that sense. And if you look at the same problem, like a sentiment classification, which was like subject of my PhD back then, if you take software 1, you have this sort of logical type of a step through for these ones. And then you have software 2, which is kind of a black box machine learning era that we went through for the past many years, especially during that time of mine in Zalando was sort of the focus. And then now we have this software 3.0 that I'm essentially saying, hey, like I would like to know the sentiment of these pieces of text, and it works. And it's relying on that underlying intelligence, and that underlying intelligence is relying on an underlying knowledge model that has come to existence. So he then goes to extend this analogy to, just like the electricity companies, like OpenAI is also like providing, things, and then there is a grid, and then there is like building the thing itself, which is the capex, and then you have the operational opex of it. And there is all this comparison from a mental model perspective that he suggests, which is also very interesting. So hence, our focus is how to use intelligence always in AI for the past many years. Every time we think about AI, how to use artificial intelligence we think in context of a form factor of an agent. And that picture is a standard kind of classic picture that you have an agent, takes inputs, outputs, that percepts actuators. And that continues to be the same. This is maturing, it's become possible, but in terms of like, you have to know what are the timeless kind of things that are talked about, and what are the capabilities that can be used on top to make things a reality. And when you think about all of that, you essentially then say, okay, what's happening in the world? There's 3 kind of key buckets in the whole AI agentic type of a world. With the generative AI, we can of course generate, so there's a lot of information or knowledge production. And then there's a whole other area, which is interesting. So it's not only generating, it's helping you summarize, understand, consume, comprehend, which is much closer to that overall Bush's kind of a primary objective, which is like how to use knowledge, which is extremely important, because what we are producing is, per year, a lot more than what the ever human has been produced in the human history. At the time of my PhD, it was like every 5 years, and now it's a lot many, many, many times faster and on an exponential level. So how to use all of that? So agentic AI emerged. This picture is almost kind of old now, after like probably 10, 12, 15 months, and you have the agents. There's different components that are important to pay attention to. There's memory, there's planning, there's tools and action. And Andrew Ng, whom I like very much, from Deep Learning AI with a lot of great courses there, he did a few of these experiments. He said, oh, I'll take a sort of a raw GPT 3.5, and then I compare it with a GPT 4, but I put the 3.5 in an agentic architecture. I put the software around it, so I empower it with the needed additional logic, and it kind of outperformed on all metrics, and that's why everyone in the past year or so from OpenAI, starting with O and everything else, went to this agentic type of a style of working with information. And hence, as a result of it, one mental model that Andre Carpati also suggests is kind of, you have the LLM, very much like the CPU, he says the OS, and then you have like the context window, which is like the RAM, or you have the different types of possibilities for the memory, and then you have the other things that get connected to it. But what is important for me is this realization that in our brain, we have something that we can kind of very obviously feel is there is a subconscious and then there is a conscious. And this subconscious is kind of, you can retrieve things from it. It's not always, you kind of retrieve, it's almost an intuition. It comes, and then there is the reflective. When it's here, then you think about it and you do it. So if I say 2 + 2, you're kind of keeping 2 and 2, and you're kind of doing it logically, right? So this is very much compatible with what was, for example, discussed in the Thinking Fast and Slow. How many people have read the book? So this is also a very famous book. Guy got also a Nobel Prize, I think 2001 or something. And now essentially, when you do your intuitive thinking, it's very fast, right? So that's the retrieval system that is there. And if you're doing your reflective thinking, you have to slow down and think about the process, what's the logic, what are the different steps. And he tries to explain this book. You have to be very conscious in which case you're using this mode, in which case you're using that mode, and what are the different biases that come with it if you're not aware of it in different circumstances. I submit to you that that whole intuitive, abstraction-based, massive data abstraction retrieval system is kind of solved to a large extent with the available LLMs now, right? So which then leaves us with a big hole up there, and that's what the agentic layer is, because that's where you do this conscious, reflective logic base. This understanding is, I think, very key. And as a result of it, from a very high level, you say, okay, I got this intelligence now inside the LLM. I got essentially two things. It's not only a language model, right? Language is just a manifestation of knowledge. So it's a knowledge model. And then you have the interface capability using this conversational. And then when you build an agent, you have to kind of extend it from all three levels. On the one level, you have to create the interface that it continues to be conversational but customized to a particular context. You have to have the workflows. That's all the overall normal software engineering workflows and logic that is around that thing that kind of delivers the software. And then you have memory. Now, in the intuitive memory, there is things there, but you want to have also this external conscious memory, and then you create all these other things like RAG and everything else there, right? So this kind of maps into what Satya also talks about as interface logic memory. In the same fashion. Now the interface is easy. We're all amazed that we have now this conversational system, and of course it's super close to us. It's most natural, way more than the sort of multi-touch, and the ability of traditional software doing the logic piece is also super clear. So everything is essentially, every agent is an LLM wrapper with different levels of depth. The one thing that is interesting, that software part to think about, is that software generally has this imperative kind of a control flow, or has a declarative control flow. But now we're kind of having this new type of an agentic, undeterministic control flow, which is goal and context based. Now from there, that perspective, context engineering, now context, sort of prompt engineering is a part of it, but context engineering as a whole, which is how to juggle with all of these things, long-term memory, short-term, what comes back from tools, etc. How do you juggle and organize this is super key, and it's rapidly evolving. So if you look at Cursor, there you have the like the ability to create these rules, which are just a file. In a file, I created a little PRD, product review requirements document. In there, I say, imagine you're a junior product manager. Here is how you write a PRD, and I have that whole instruction ready there. Now, this is from a YouTube video from Brian Carson, and he then uses their create. So you then call the context, you say create PRD, and then I'd like to do this. So you're giving this context that you've explained, like how you do the whole thing, and just use it and just move forward. Then you say, okay, just like a product manager, I thought about the whole thing from a PRD perspective, and then I would like to break it down into tasks. And you have another little cursor rule that gives you this breakdown of tasks, and then you go ahead and essentially call it in that sense, so that you say, you create another one that say, okay, then here's how you deal with the task, how you execute the thing, and you just say, okay, execute this list of tasks, and essentially that's how you control the overall. So it's different from going to cursor and say, hey, just build me this, versus saying, hey, give me a very good PRD first, then give me a very detailed instruction steps. Okay, we're going to start with step 1. Here's how we do step 1. And then you control the environment at the production level AI production. And there, of course, context builders becomes very important. Git ingest is a very good example of it. You can copy paste all the files you got there. Repo prompt is another one. You can just, from your repo, if you want to do this manual context curation, you use these things. Now, overall, all the things are being made ready for build for LLM. For example, there's a proposal to go from robots.txt to LLMs.txt, and then the same thing for docs for the LLMs. That can be created. And of course, the docs creation itself can be improved radically, and then there's different actions that can be done in docs, and those docs can be also actionable by the LLMs directly. So in a case of an MCP server in Cursor, you can just enable an MCP server for browser-based, which is a headless browser, and then it's sort of from Cursor, you say, hey, go to this website, screenshot this, or do that, and that does it for you. So 3 sort of closing examples. One is this: if you look at Cursor AI as an agent, you see these 3 things that we have talked about. Same thing: context, orchestration. There's of course the sort of the interface super key, and the same thing is with regards to perplexity. And all of that, so this overall understanding of what agents are, and that inspiration for Bush, we're trying to do another one with what's called FileButler.ai. It's an app on your Mac or desktop in general, and it's going to do things like, you essentially talk to it and you say, open this file, open that file, rename this, organize it, what's important in my files, and that overall interaction with desktop and knowledge records can be reimagined. As a result of it, you can look at architectures like this, that, where's the intention identified, where's the contextual knowledge graph, etc., etc. I think we made it. Thank you very much.